11 students. Nice to see you again. I am teacher Gisela Esquinas from the San Luis Oriental General Comprehensive High School, Senior High School, Division of Miss San Luis Oriental. I am your teacher for this learning episode on Earth and Life Science. Before we begin with our new topic for today, let us have a brief recap of our previous lesson. In the previous lesson, we talked about the Earth's internal heat. We consider heat as one of the extreme factors to make Earth inhabitable. Earth's internal heat could move continents, build mountains, and cause volcanic earthquakes. Can you still remember the two known sources of Earth's internal heat? You got it right! The first one is primordial heat, which was gradually gathered together by means of dispersion in the planet during the early formation of the Earth. The second source of heat in our planet is the radiogenic heat. This is the thermal energy released as a result of spontaneous nuclear disintegration. There are different ways to transfer heat.
Conduction governs the thermal conditions in almost the entire solid portions of the Earth and plays a very important role in the Earth's surface. Convection happens at the mantle, but never in between the core and mantle.
Moving on for today's lesson, we will be discussing the changes in mineral components and texture of rocks due to the changes in pressure and temperature, which is known to be the process of metamorphism. Now that we know where the heat of our planet comes from, let us focus on the process of metamorphism. Are you familiar with the rock cycle? The rock cycle is a concept used to explain how the three basic rock types are related and how Earth processes over geologic time change a rock from one type into another. Plate tectonic activity, along with weathering and erosional processes, are responsible for the continued recycling of rocks.
The rock cycle is a group of changes. Igneous rock can change into sedimentary rock or into metamorphic rock. Sedimentary rock can change into metamorphic rock or into igneous rock, while metamorphic rock can change into either igneous or sedimentary rock.
We have already discussed the three types of rocks and how they are formed. I am sure that you already encountered the word metamorphism. Metamorphism is a change in the structure, texture, or composition of rocks subjected to conditions that are different from those which it is formed. It is from the Greek word meta, which means change, and morphe, which means form.
Metamorphic rocks form when rocks are subjected to high heat, high pressure, hot mineral-rich fluids, or, more commonly, some combination of these factors. Conditions like these are found deep within the Earth, or where tectonic plates meet. The process of metamorphism does not melt the rocks, but instead transforms them into denser, more compact rocks. New minerals are created either by rearrangement of mineral components or by reactions with fluids that enter the rock.
Pressure or temperature can even change previously metamorphosed rocks into new types. Metamorphic rocks are often squished, smeared out, or folded. Despite these uncomfortable conditions, metamorphic rocks do not get hot enough to melt, or they would become igneous rocks. Do you know the three main factors of metamorphism? Correct. This includes heat, pressure, and chemically active fluids. The heat perhaps is the most important factor because it provides the energy to drive the chemical changes which results in the recrystallization of minerals. The heat increases as the depth increases.
Pressure, just like heat, also increases with depth, and the buried rocks are subjected to the force or stress. Heat and pressure causes physical changes to buried rocks. Chemically active fluids enhance the metamorphic process. Usually, the common fluid which helps the chemical activity is water, containing ions in solution.
So what are examples of metamorphic rocks? Slate is produced due to low-grade metamorphism of shale, which is used for classroom blackboards and pool tabletops. Schist has mica crystals from metamorphism of clay and feldspar. Anthracite is the metamorphism of bituminous coal. Gneiss is produced due to high-grade metamorphism. And lastly, marble is formed through the metamorphism of limestone, which is used in the construction of building floors, walls, and counterparts. Now we have reached the end of our journey for today. Let us recap what we have learned. We discussed about the process of metamorphism, in which new minerals are created either by rearrangement of mineral components or by reactions with fluids that enter the rocks. Pressure or temperature can even change previously metamorphosed rocks into new types. It's time for a short assessment of our topics today. Prepare a ball pen and a piece of paper to answer the following questions. I will repeat each question twice. You'll be given 5 seconds to answer each question. Ready? Let's begin.
Number 1. What is metamorphism? Again, what is metamorphism? Number 2. What are the three main factors of metamorphism? Again, what are the three main factors of metamorphism? Number 3. Give 2 examples of metamorphic rocks that has commercial uses. Again, give 2 examples of metamorphic rocks that has commercial uses.
Congratulations! We are done with our short quiz for today. Please submit your output to your respective subject teacher via messenger or email. And that ends our lesson for today. I hope you enjoyed and learned something. Again, I am teacher Giselle from the Misamis Oriental General Comprehensive High School. School, Senior High School, Division of Misamis Oriental. Tune in for another learning